Hi everyone, this is Ramalinga Prasad Kuppa. Welcome to my channel, Pharma World. Today's topic is LOD and KF. Loss and drying, which is abbreviated as LOD, provides information on all residual volatile matter in the product. LOD includes any traces of water content in addition to other potential organic solvent residues that are likely to be present in the final product. KF is a specific test method for determination of water content in the product. Water content is sometimes called as moisture content. The reason is that since the presence of water will be in very less amount traces, it is called as moisture content. Let us understand more about these two typical tests. LOD. LOD is loss on drying. Conceptually, in this test, the product is dried at a specific temperature where the residual solvents in the product evaporate. This helps estimation of the residual content. There will be an acceptable limit for the LOD content. This is the estimation of all volatile residuals in the product. Obviously, all solvents present will evaporate at the temperature where the product is exposed in an oven. Generally, the drying temperature will be higher than the boiling point of the residual solvent present in the product. The residuals include organic volatile impurities OVI that are part of the process and left over as residues in the final product. Generally, OVA refers to the residual organic solvents that may be present in the final product. These are listed as Class 1, Class 2, and Class 3 in USP 467. USP Chapter 467 prescribes upper limit for these three classes of residual solvents. Depending upon the toxic nature of the solvent, they are classified as 1, 2, and 3. Water, if present, also is considered as volatile impurity. So, if water is present, generally the LOD test will be done at 105 degrees Celsius because water boiling point is 100 degrees Celsius. KF. KF is Karl-Fischer titration method for estimation of water content or moisture content exclusively. This is specifically designed for water content determination. This is a quantitative reaction between iodine and water in the presence of sulfur dioxide. This is an accurate quantitative reaction for water content estimation. This method is also useful for estimation of adsorbed water content in hydrated compounds. Water content in hydrates can also be estimated accurately with this method. USP 921 provides detailed methodology for water content determination. So, more detailed information on the titration method are available in this chapter USP 921. Let us compare the LOD test and KF test. LOD will be more than KF in many cases. This is because in addition to water, there could be other solvents present as residues. Hence, LOD will be higher when compared to KF test. LOD is carried out at different temperature conditions. Depending upon the boiling point of the residual solvent, the temperature for LOD will be assigned. It may be 60 degrees Celsius or 80 degrees Celsius or 105 degrees Celsius, etc. LOD is carried out at atmospheric conditions and under vacuum, also depending upon the product characteristics. For products that are stable at higher temperatures, LOD can be done under atmospheric conditions. Certain low melting materials melt at higher temperatures. Hence, vacuum is applied to the drying oven and LOD can be carried out at lower temperatures like 40 degrees Celsius or 50 degrees Celsius. LOD is equal to KF value if the final residual solvent is only water and no other organic solvents are present. This is a logical situation. LOD test takes longer, generally around 3 hours, whereas Kalfisher titration takes much less time. LOD is a slow process and takes longer test time, whereas KF can be done at much less time. But of course, KF can estimate only water content. Let us see how the assay calculations are done using LOD and KF. Assay of a compound is calculated as such on anhydrous basis and on dried basis. So there are three ways to report the assay content. As is basis, in this there is no correction required. On anhydrous basis, as such assay value is multiplied by 100 divided by 100 minus percent KF. Anhydrous basis means, by definition, the content after making correction for the water content present in the product. Simple way to understand. On dried basis means, as such assay value is multiplied by 100 divided by 100 minus total of percent LOD and Kalfisher. On dried basis means it includes any possible solvents and water also if present. Correction for water may also be made in such cases from LOD values. Some products are tested for LOD at lower temperatures less than 105 degrees Celsius. In such cases, water, if present, may not appear in the LOD test result. Assay by dried basis or anhydrous basis will be more than as such basis. This is a simple linear equation to understand. I hope that the information on the comparison of LOD and KF tests is useful. These two tests look like giving the same information or similar information, but there are obvious differences in these both the tests. LOD and Kalfisher values are used for calculating the assay value on 100% basis. Thanks for watching. For more videos, please do subscribe, like and share. Also, please leave a message in the comments box for any further support. Thank you.